Out of 2,000 families with 4 children, how many would you expect to have 2 boys, no girls, and at least 1 boy? Alright, so just forget about the 2,000 at the start. Just forget about that. 4 children and what you're expecting. So, probability of a boy is a half. Probability of a girl is a half. Alright? And you got to remember, it could be a bit like this, couldn't it? It could be 2 boys, could be boy, girl, girl, boy, girl. We don't have to worry about any of that, do we? Why do we not have to worry about that? Because we have our equation here. We have NCR, P to the power of R, Q to the power of N minus R. So let's try that out. Alright, you have 4 children in your family. You want 2 of them to be boys. This means you have a half to the power of 2, because the R value is 2, and then 4 take away 2 is also 2. So that's the probability, isn't it? What you need to do with this answer then? Multiply it by? What would you multiply it by? Multiply it by 2,000 and you should be able to figure out. So the probability is 3/8 when you throw all that into the calculator. And then what's 3/8 of 2,000? Well, 3/8 of 2,000 is 750 families. We all good? Alright. The next one. Next one is you have no girls. No girls means you have 4 boys. That is grim. And so 4 C4, 4 boys, 0 girls, and you throw all that into the calculator and you get I think it's 1/16, and then 1/16 is your probability of having 4 boys in a family, and then you multiply that by 2,000 and you get an answer of 125 families. Okay. The next one, at least 1 boy. Now how are we going to do that? Why don't we do 1 take away the probability of no boys. Does that make sense? 1 take away the probability of no boys is the same as the probability of 1 boy, 2 boys, 3 boys and 4 boys. That's 4 different parts, isn't it? It'll take a long time to do that. Now, does anybody have a really quick way of doing this? The probability of boys and girls is the same, isn't it? So the probability of no boys is identical to the probability of no girls. Does that make sense? So it's actually the same thing. Okay? But if you weren't certain of that, here's what you do. You do 4C0, no boys, a half to the power of 0, and a half to the power of 4. And you realise it's exactly the same answer as last time. So it's going to be 1 take away 1/16, which is 15/16. 15/16 is the probability that you have at least 1 boy. And then you multiply that by your 2,000 families, and you get 1,875 families at least have 1 boy out of the 2,000. Any questions? I'll pause it. Alright, let's move on. So I'll go for 20 first. A fair coin is tossed repeatedly until the 3rd head appears. Explain how you use the binomial distribution to work out the probability of this happening. Okay, first of all, when you toss a coin, what do you have? There's 2 outcomes, getting heads or getting tails, okay? Heads or tails. Okay. Next thing, let the probability of success be what you want to. So it depends. You're just basically saying what your P and your Q value is. So my p-value is a half. So for argument's sake, I'm saying success is heads, failure is tails. It doesn't have to be that way, but it's just the way I'm setting it up. So probability of success is probability of a head, which is equal to a half. Probability of fail is equal to the probability of tails, which is also equal to a half. Happy days. And that's just pretty much just describing how you'd go about doing it. That's all. And you just say that this is a Bernoulli trial because the outcome of one flick of the coin doesn't affect the outcome of the next flick of the coin, so therefore we can use the binomial distribution. Okay, that's it. It's a bit wish-washy of a question, if I'm being honest. Wasn't the best question. 22. A card is drawn from normal deck of playing cards and then replaced. If it's replaced, what does that automatically mean? It's an independent event, that the outcome of one pick of the card doesn't affect the next one. Alright, a card is drawn repeatedly and then replaced until the third picture card is drawn. Oh, sorry. Let's start with part 1. Alright, what's the probability of a picture card, anybody? How many cards are picture cards? King, Queen, Jack. And there's 4 suits, isn't there? So that's 12 cards out of 52, otherwise known as 3 out of 13. Okay, so let's call that P for success. That means 10 out of 13 will be fails. Find that the third picture card is drawn on the 13th attempt. So what position do you need to be on? 2 picture cards in 12 attempts. So you need to have 2 picture cards in 12 attempts so that you're in a position to get the third one on the 13th attempt. So 12, so it's what's it, NCR, P to the power of R, Q to the power of N minus R. Alright, so we're going to go for 3 out of 13 to the power of 2. And we're going to go for 10 out of 13 to the power of 10. That's your probability of getting the your 2 face cards out of 12. Alright? What are you going to multiply that by? What's your probability of getting the face card on the 13th pull? So you lob all of this into the calculator, and what I'm hoping it comes out as is 0.0588. Did anybody else get that? Yeah. Exactly like that? Barry? Could you just explain why you have 12 there? Alright, so it says third picture card on the 13th attempt. Alright? So it says third picture card on the 13th attempt. So that means after your 12th attempt, you're only successful twice. So then when you get your third success, it has to be on the 13th attempt. So that's why we find the probability that you have 2 successes in 12 attempts. Okay? And then you multiply it by the probability of being successful in the 13th attempt. Alright guys, is that everything from that exercise? Happy days. Alright.